9.5 is factoring the differences of perfect squares. So this is the fifth type of factoring that you have learned. And the times you'll be able to use this is there can only be two terms. Oops. When you have two terms, you'll be able to use differences of perfect squares. And you must have subtraction, because that's what the difference of two perfect squares mean. And you must have two perfect squares. So let's review really fast what you know about perfect squares already, because we studied it earlier in the year. And you will know something's a perfect square, like 9, if you can multiply a number times itself and get 9, then 9 is a perfect square. So 1 is a perfect square because 1 times 1 equals 1. 2 is not, 3 is not, 4 is a perfect square, and then 9 is the next one, then 16, then 25, then 36, 49. So we made this list at the beginning of the year, and they now have to be really familiar to you to know that these are all perfect squares. Same thing with, it's also true that you can be a perfect square if you are a variable, because a times a equals a squared. This is a perfect square. A to the fourth is also a perfect square because a squared times a squared is a to the fourth. So even exponents will make perfect squares. Because remember, when we are multiplying these two things together, we are adding their exponents. So if it doesn't have an even exponent, a to the fifth is not a perfect square. So hopefully you're pretty familiar with all the perfect squares, and you might have to guess at them if it gets to higher numbers. You might not remember. Things like 169 is a perfect square, 13 times 13. So you're going to try to, if you don't recognize that it's perfect square right away, you're going to try to multiply something times itself and see if that works. So when you do have perfect squares, then if there's two perfect squares, like a squared minus b squared, then they will factor. And they're always going to factor into the same pattern, a really simple pattern, that if I say to factor this, these are two perfect squares, they're being separated by a minus sign, so therefore this is the difference of two perfect squares. They will factor into two binomials, a plus b and a minus b. So this would be the answer if I asked you to factor a squared minus b squared. Now let's FOIL it to remember why. You're going to multiply here and here. So that's a squared minus ab. Then you're going to multiply here and here. So that's plus ab and minus b squared. These middle two terms, negative ab plus ab, cancel out. You should remember doing these. These were special products from chapter 8. When these cancel out, you end up with a squared minus b squared. So if I gave you x squared minus 9, this factors into x plus 3, x plus 3 times x minus 3. So once again, try to FOIL it to see why that works. This is my answer, but I'm going to FOIL to see why. X squared minus 3x plus 3x minus 9. Middle two terms cancel out. I have x squared minus 9. So when I'm looking at it in the beginning, I'm saying to myself, there are two terms. Each one of them is a perfect square, and there's a minus in between. Therefore, I can factor with this pattern. You're basically taking the square root of the first term and the square root of the second term, putting a plus with one, a minus with the other. So if I give a squared minus 49, really simple, a plus 7, a minus 7. Of course, if you gave me the answer with the minus first and then the plus, that's totally the same. They're both absolutely fine. So this is your answer if it says to factor, and we see that these are both perfect squares with a minus in between. Now, we need to talk about when you have a plus in between. So if I give you x squared plus 25, and I say, can you factor this? Well, these are both perfect squares. X squared and 25 are perfect squares, but it has a plus in between, not a minus. Therefore, no, you can't factor it, and it's going to be prime. But people tend to not believe me when I show them this, so I always let people try to figure it out. So think about if you were trying to factor this, and say you thought the answer was x plus 5 times x plus 5, which people often do. Well, let's FOIL this out and see why it doesn't work. So I'm going to multiply here and here. So that's x squared plus 5x. Then I'm going to multiply in here and here. So that's plus 5x plus 25. These middle two terms will add together and give 10x plus 25. So this did not factor into x plus 5, x plus 5, because when you multiply that together, you get three terms. So if I had, this will not factor, this is going to be prime if it has this plus in between. Having said that, if I give you negative 49 plus a squared, well, this has a plus in between, but you can factor this. It is still the difference of two perfect squares, because if I rearrange it and decide to put this one first and then minus 49, now you can see clearly that it is the difference of two perfect squares, and it does factor into a plus 7, a minus 7. So a lot of the problems are nice and easy like this, no big deal. But it does get a little more difficult. So let's try to factor this. And I will add some equations in also. And by now you should be able to figure out how to do the equations once you've learned the factoring. So 36x squared minus 49y squared. Now they're all perfect squares. 36 is a perfect square, x squared is, 49 is, y squared is, and it does have a minus in between. So when I go to factor it and put my two sets of parentheses, in the first set I think to myself, what times what is 36? That would be a 6. And what times what is x squared? That would be an x. So they're both 6x. And for the other one, 49 and y would be 7y for both of them. I put a plus on one, a minus on the other, and that problem is all done. Next problem, we're going to factor 48a to the third minus 12a. Well, these are not perfect squares. A to the third is not, 48 is not, 12 is not, because what number times itself is 48? What number times itself is 12? Nothing. However, the pledge was the first type of factoring I will always try is GCF. And sure enough, now you're going to see a lot of GCFs, and you've got to remember to try to factor it out in the very beginning. So the GCF in this problem is 12a. And when I factor it out, I end up with 4a squared minus 1. So after you factor the first time with GCF, there is a second type of factoring, and you always will look in the parentheses and ask yourself, is there a second type of factoring I can do? And yes, there is for this one. Inside the parentheses, I do have the difference of perfect squares. I've got a minus sign, and remember 1 is a perfect square because 1 times 1 equals 1. So when I go to factor what's in the parentheses, I must rewrite and bring this part down. This is going to be part of my answer. This 12a cannot get lost. Now the 4a squared minus 1 is going to go to 2a and 2a, 1 and 1, with a plus on one, minus on the other. I'm going to look again into the parentheses and see could I factor again. And this time, no. This is as much as I can factor, and that is my whole answer right there. Another similar one, 2x to the fourth minus 162. So the first type of factoring I will always try is GCF. This one does have a GCF. It is just 2. And that will give me x to the fourth minus 81. So that was the first type of factoring. Second type of factoring I can do, I look in the parentheses, I see two terms, I see a minus sign, I'm looking for perfect squares, and there are, because x squared times x squared equals x to the fourth, and 9 times 9 equals 81. So I don't lose the 2, I gotta write that, and I'm going to write x to the x squared and 9, make one of them plus and one minus. But don't ever think you're done with the problem, because if I look in this parentheses, I see one more set of perfect squares with a minus in between. So I bring down the 2, I bring down the x squared plus 9. Don't lose these, they're part of your answer. And now I'm going to factor this part, x squared minus 9 will give me x plus 3, x minus 3. And this is my whole answer to that one. So there will be many times when you're going to factor more than once. Definitely lots of times when you'll factor twice, and possibly times when you will factor a third time. Now I'm going to do an equation to make sure that you can apply all the rules that we've learned and solve equations. So there is an equal sign, and the problem will say solve. And the first step is always to get the problem set equal to 0. So every equation we've had in this chapter, we start with that first step, get it equal to 0. So I'm subtracting 50x. I get 18x to the third minus 50x equals 0. Second step is to factor, and I will be looking for a GCF. First type of factoring I'll always try is GCF. So the GCF of this problem is there's a 2 and there's also an x. When I factor out the GCF, on the inside I get 9x squared minus 25 equals 0. I can factor more, because as I look into the parentheses, I see there's two terms, and factor more. There's two terms, and they're separated by minus, and they're all perfect squares. So they will factor into, I don't want to lose this 2x, especially not now, when I'm solving. So I have the 2x, I have 3x plus 5, I have 3x minus 5 equals 0. Now, I'm ready to set each part equal to 0. Because I've started with my largest exponent as a 3, that tells me I'm going to have 3 answers. If the largest exponent is 2, you could have 2 answers. The largest exponent is 3, you're going to be looking for 3 answers. So I'm separating it into 1, 2, 3 different parts. The first one says 2x, and you set each equal to 0. The first one is 2x equals 0, divide by 2, and x equals 0. Don't lose that one answer, because that'll cost you if you lose it. The second part, 3x plus 5 equals 0, we solve. 3x equals negative 5, divide by 3, and I've got negative 5/3. The other one's going to come out to be, sorry, didn't mean to scare you, but, save the project, yes. The next one is 3x minus 5 equals 0, add 5, 3x equals 5, and I have the positive 5/3. So I'll write all 3 answers, negative 5/3, 0, and positive 5/3. Now your book will often do this. They'll call it 0 and plus or minus 5/3. And that's the way they show all 3 answers. You can do it either way. Just make sure it's really clear if you're putting the plus or minus. If you want to be safer, just show me all 3 answers. Okay, let me do another one of those. Let's do, find a good one. Let's do 121a equals 49 a to the 3rd. So if I started by setting equal to 0, and I subtracted here, negative 49a to the 3rd, I'd have 121a minus 49a to the 3rd. Now it's set equal to 0, and now my next step 1 is done. Step 2 is to factor, and I'm looking for a GCF. I believe the GCF is just a, so I factor out an a, get 121 minus 49a squared equals 0. Now inside the parentheses, I have the difference of perfect squares, so I factor again. Don't lose the a. This will be 11 plus 7a times 11 minus 7a equals 0. I'm now ready to set each part equal to 0, and there was the highest exponent of 3, so I am seeing that I'm going to have 3 answers. I'm separating it here and here. The first answer, a equals 0. The next one is going to be 7a equals negative 11. So negative 11 over 7. And the last one's going to be positive 11 over 7. So I'll write my answers here. Negative 11 over 7, 0, comma, positive 11 over 7. And there's all 3 of them.